So this is the PCB that we're gonna solder a few components on it. You see, it has different buttons, has a resistor, LED, and a micro USB. You have on your top of the table a empty PCB that is like this. Empty PCBs, we try to touch with your fingers less as possible because it gets rusty. We can clean it later, but it's not a big deal if we touch it meanwhile we solder. It's normal. It might happen that your PCB has this outcome that is an ugly cut. That sometimes happens because you didn't set up the set or the values on the machine properly, or just the end mill was old and it doesn't cut really well. So what we do to fix a PCB that is like that? What we do is we don't throw it. What we do is we take a little piece of sandpaper. Please don't take, like me, a piece of machine. Just take plain sandpaper and look for a sandpaper that has a really small grain. When I make really small grain, it's usually the opposite. Sanding papers are meant with grid names. A high number means a really thin grain. So a 3000 number is really soft. Meanwhile, a low number like 100 is really aggressive. We want to use a really, really thin one. So what we do is just put the PCB and sand it a little bit. Huh? So the PCB has been scrapped, but now it's not dirty, and we have clean edges. Let's look at the microscope camera. Woo! You see that the copper is completely scratched, but it's not a big deal. So what else we need to find in the PCBs? For example, here we see that we have a leftover part. Can you close the door, please? So these are the traces. These are the traces, and we have some leftover parts like this one. This one is a really, 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 really thin piece of copper that can get damaged and make a short like this. Meanwhile, you solder. So this kind of pieces of copper, we always want to cut them. We can use the tweezers, or sometimes we need to use a cutter knife. So we want to break out these little pieces of copper. We just blow, and now this is clean and perfect. And we make a visual inspection for this kind of little bridges.
You have the cross, no?
This cross?
No. But yes, there.
The cross is on purpose. Actually, it means that this is positive and this one is negative.
Okay.
Sometimes we leave these ones.
Okay.
If this was loose in the cut or was really thin enough and might make it loose, I would take it out, even if it was on my design.
Okay.
So how we check that? Usually when you have seen that to produce a PCB, you have these like images that you can compare to your real PCB to see what is actually a trace and what is not a trace, and are the components that you can take out.
Okay. But you don't have the curves in the lines in the original one.
Yep. So more or less, okay, for example, look, we have a little piece of copper here that is dirty and it will make a short. So we need to clean it out.
And you have another one there between the four lines.
Exactly. For example, in this case, this was not really good cut and that will easily make a short. So I will do is just pass the tweezers between.
Where can we find this microscope camera?
It's a Soldering, right?
Is Amazon microscope camera.
They sell them on.
Yeah.
So how to do this? Right now you have a microscope camera, but normal use of the lab is we have this augmentation lens that are clamps that helps to solder, and we have also these ones that are fixed on the tables that you have augmentation lens with light that are more useful. This depends a lot on your soldering and what you want to solder, the size and scale. But for example, most of the cases I never I never use either augmentation lens or clamps. My personal choice is always, if you look at my setup right now, is use a cutting mat. Like it's not a cutting mat, it's a soldering mat. It's silicone. You should not cut because this happens.
Okay.
That someone broke it. And it's heat resistant. And in case we touch with soldering iron, it doesn't burn. If you leave it for 5 minutes, yes, you will damage the silicone. Silicone resists, I think, 300 something degrees, almost 400 for a while. That usually has these little holes to let the components so we don't mix them. My personal choice is always to have only one component on the table open at once. Why? So I don't mix the components and I don't mismatch the labels. What else we need? There are two different styles of tweezers. You have flat tweezers and curved tweezers. My recommendation is, in general, curved tweezers are more comfortable. And tweezers, you need to be really delicate. You see that the point needs to touch first than the bottom of the curve. Like that, you are able to grab the components in an easier way. If somehow happened that someone has bent the points, you can bend it with your fingers a little bit or use a little clamp to help them bend to the inside. But be gentle with them. You can bend them really easily. What else we need? We need solder. Solder, there's a big discussion on actually lead is toxic, but lead makes soldering so much easier. So you try to use the less amount of solder, lead inside your solder as possible. In this case, a 2.2 is not a really high number, but it's still not like, don't try to smell all the fumes that come out from the from the soldering. Soldering irons can come in different form factors. For example, here we have a soldering station. Those are regulated, and you can change actually the temperature. It depends on the soldering temperature. Usually you solder around 300, 320 degrees. You might see that right now I have 400 because I do usually a fast soldering. I just touch for a few seconds the components. In general, it's way better to learn with 320 degrees because if you overheat the components, they might break. So you don't want to overheat them, but you neither want to under solder or have a what is called a cold solder. Components have sometimes.
But you have 400 degrees or?
I have 400 right now.
Okay.
Because I'm doing a fast demo.
Okay.
So, for example, this is a button that you have on your table. Buttons like this have orientation. You see that the button has 1, 2, and the other side has 3 and 4 legs. This button.
This for the moment.
Thank
you.
Take the lens. Yeah. This how to know what orientation does this button has. The best way, and you will learn this in electronic design, is opening the datasheet, component datasheet. That if your inventory is more or less clean, you will have little boxes and trays that have the components and the serial number of the datasheet of the component. If you put this number just into Google, it will automatically go to the datasheet, and you might find like the manufacturer description on, okay, this button is a 3x3 button, has this dimension, this pin connects to this pin, and has the technical and the the specifications of the button. Just to make it simple for now, we will see that your board has these 4 connections. We can just try to find where the button goes. Then you will see that it matches the sizing of the legs because we have designed it with a specific software to design based on the components. So if you try to place it over the top, you will see that the component matches the footprint perfectly. So how to solder? Be careful with the soldering iron and never, ever leave the soldering iron on the table. You might you don't know how many height. You don't know how many people have seen burned their hands or their laptops or the headset or whatever there was on the table because of this. So you always use the soldering holder, soldering iron holder, a specific one. Be really careful because most of soldering iron holders, they are empty in the back. And it's also a common mistake that a cable is really close and the cable starts melting because it's touching the point. That means you will make a shortcut and it's a 220 volts shortcut. That actually happens every year. Once a year, at least the fuses of the building went down because someone has melted the cable. So be careful with this. All this metal part of the soldering iron is hot. It's at the temperature just set up. In your case, that are fixed temperature soldering irons, is at 300 degrees in average. Also, when you work in pairs, you never give the soldering iron. Why? I've seen also a few people grabbing it from the hot area, and basically that's going to the hospital with a 3-degree burn on your hand. So always you leave it on the holder and the other person grab it. You never pass the soldering iron. That's basic safety workflows. How to solder? My recommendation is always don't take the full roll, just take a little bit, break it. I wrap it in a circle around my finger so I can hold it like that. And let's take the soldering iron. I will change the camera. Okay, so in general, a lot of people that they usually do that mistake is the beginner's mistake is they put solder on the soldering iron. No, no, never. So what you do is you hit the thing that you want to solder, not the soldering iron. So if we want to place this component, what is the tweezer? Here. So if you want to solder this component, soldering, holding the component, and now I need a third hand. I don't have it. So what we do is we touch the copper, we put solder on the copper. It will take a while to get, but suddenly starts melting. You see it's a bubble, it's a bubble, it's a bubble, and at a certain point, you see, it flows. This is a good temperature solder. If you have a ball, it's a bad temperature solder. Let's see with a drawing. So a solder that looks like this is a bad solder. It's a cold solder. The material didn't got hot enough. And this material is flowing, is a good solder. So don't be a ball, flow with the solder. So now that the solder is in place, let's heat it up again. And let's take the component, meanwhile, and let's put in this location. And let's wait that the solder also grabs the little leg. And I take the time to locate it correctly. Now, the solder might not be perfect right now, but the first solder we do, yeah, ideally you should do this meanwhile at the same time, but I understand this is the first time, is I use the first solder to locate my component. Now, I can actually solder in a good way the other legs.
So that you can see better.
So you solder one leg, second leg, and we turn, and we solder the third, and we come back, because you see that here the solder is different than in this side. In this side we see a little bit of the leg. So what we do is just hit a little bit more the solder. And you have seen that I have made a little bit short in there. So how to fix this? First, in your soldering iron stations, you should have a sponge that needs to be wet. You need to make it wet, the sponge, always. Don't do it in a dry sponge. And some other soldering stations have also some metal bread that you can just scrap against it. So always do it mean each different solder point. Always clean a little bit the solder point. It needs to be really clean, as the excess of solder on the point will actually make shortcuts in general. So what we do is I will just reheat it. In most of the cases, this gets fixed. It still didn't get fixed. How we can solve, for example, this connection between this area and this area? There are different techniques. One is use the solder sucker. That is actually a piston that you press down, creates vacuum, you press and absorbs the material. These guys needs to be cleaned after the use. So you see that, you will see that a lot of people don't clean them. You press, you suck, and actually what happened is a lot of solder came out. It means because the deposit is full. So you can screw it, clean it from the excess of socket solder, screw it back, and now you are ready to use it.
Looks like a pump.
It's like a pump, yeah.
Okay.
You have a second type that is a soldering iron solder sucker. It's the same, but all in one. It's the same concept. And we have also, oh my God, this, I hate these things. So many.
Can I help you?
I need a soldering station. And you have another one that is the copper bread that is there. That this is magic, but also students tend to use it a lot. That is basically a copper cable, nickel threaded wire. So usually this is really good, but the students tend to overuse it, and this is not something especially cheap. So I will do the example in a clean side, so it's easier to see, and then we will go on to the bottom. Let's say we have made an excess of solder. Like I will put a lot of solder, I don't care. Really a lot. Okay, I have made a bad connection. So first, we clean the point that has excess of solder. Okay, now what we can do is, for example, put the solder debraid, copper, on top, and let it heat. You see that the melt starts grabbing a little bit of solder.
So it absorbs the.
It's like a sponge, yeah.
Oh,
And now it's clean, and the excess of solder is in the copper bread. Still, it's not completely clean, so we will repeat again with a new area of the
and
copper.
You can't reuse it.
Hmm?
You can't reuse
No,
it.
you can't reuse it. You need to throw it. So we cut. We don't see in the camera. We cut the excess out. So we have a new point.
Okay.
Another option will be
The pump.
pump, the solder sucker. So let's make a new bump. Okay. In this case, I will use the mechanical one. So we preload, we heat, and then get close and suck. Does the same effect. Sometimes takes a little, not a lot, and you need to repeat like twice. I always press and release a few times outside my PCB, so I'm pretty sure nothing is going to fall off the deposit. Okay, more or less clean. But you see still that we have a little bubbles that is easy to just pass a little bit the soldering iron around, so we grab them with the soldering iron. Okay, and we have the soldering iron solder sucker that does the same, but instead of having just two hands, we just do it with one. So we can grab and hold the PCB with the other hand, etc. It's slightly more difficult to find this one. Solder suckers are really generic. So how we place, for example, an LED. An LED or a resistor, they have the same footprint. These little guys. And you see that the LED has two pads. Capacitor, resistor, this is a 1206 component SMD. It means 12 by 06 on size. And you see that resistors are diodes. Diodes have polarity. Resistor and capacitor, in general, they don't have polarity, unless it's a polarized capacitor. Oscar will explain a little bit in deep that part. So resistors have a direction, and resistors usually have a green line. In this case, in the microscope, it's really easy to see. On naked eye, it's not that easy to see.
No.
So you need to twist it three-dimensionally to actually see the component. They might have a line or a green dot in one of the corners. But all the components that need orientation, they are asymmetric. So if you don't know if the component has direction, just try to look for a differentiating marks in one of the sides of the component.
And the mark means
The mark in the diodes, in general, means the negative side, the cathode. If we don't know, for the component, what we can do is look for the datasheet. In the datasheet, they will also state all the specifications. So for example, let's state that I don't know this LED specification. What I can do is look for the components. Let's look for the button, for example. I have the datasheet of the button here. So we have the tray. Let's look in ISDA 262 CTND. I'm just putting the serial number, and the first link that opens up is actually the datasheet, or the third link. Actually, the first three links worked. I can click in datasheet. It will, no, I will not go here. I will go for the first link. Usually it's the best one. Okay, exactly. It's the button. Let's go for datasheet. Where is datasheet? Datasheet. Ojos datos. Datasheet. Downloaded the datasheet. I can open it. And it's stating everything of the component, like if it's waterproof or not, temperature that can work, working temperature, and also how is the connection inside and the size, and what is the space that you need for the footprint, and how is the connection working inside. So with all the data sheets, all the manufacturers state the specification of the component, and you have all the data sheets for most of the SMD components. For example, this button is a 4 pages data sheet. A resistor usually is 1 page. A microcontroller could be 300, 600 pages. Depends on the complexity of the component. It's more or less complicated. So let's solder the resistor.
it's possible that you don't see the green line.
It's there.
Yeah, but I have this, and even with this, I can't see it, and I have extra light right
The small augmentation lens are lower than this one.
now. Okay.
So that depends. For example, if this you start to get used to, and for example, Oscar, Joseph, or me, we solder without anything, just solder and tweezers. So when you start it, that's way more complicated than understand. So actually, all the helps like microscopes or augmentation lamps helps a lot. Even so, some components are really difficult to solder, and we still like need these helpers. So let's solder, for example, the resistor in these two pads. So we can see first that the component matches the paths. But you see this, the negative states this line is negative. So if this is negative and this is positive, we know that the component needs to be located like this, with the green line on the negative side. So first, we always put solder. Let's put a little bit of solder. Okay. It's a little bit out of frame. And now I will locate the LED. Okay. I don't care if it's not exactly in the best or in the best solder in one side. What I will do is fix the other side. That will help me to fix the component in place, and then I can re-go again in the solder points to fix them and make them completely clean. So we put solder. You see how it flows? This is good solder. Maybe it's missing a little bit of solder. Doesn't have too much. So let's put a little bit more solder. Okay, and you see that, oh, guys, look. You see right now that one side is shiny and the other one not? Yes. That means that is a cold solder. That means the solder wet didn't get hot enough. So we need to redo it and just reheat it. The solder needs to be shiny. Okay, in this case it's not getting, let's add a little bit more just in case, that might help. Okay. And now let's go back and redo the original one. Okay, good enough. For example, here I have added a little bit of solder. I can just take it out with the soldering. Yes?
Yes, ma'am.
Dime.
No.
Ah. So you have some components, for example, soldering irons, solder, in general, is not just a solder thread. Inside, where is my mouse? Inside has a little bit of flux. Flux is a chemical component that allows us to solder easier. You see that the color of these areas, you see that when we solder, this becomes like darky, because if we look at the microscope, we will not see, but inside the thread, we have a little bit of flux. Flux is a chemical component that is quite toxic in general, but helps a lot in the soldering. We have it also in like paste or liquid form, and it looks like Vaseline in case of the paste. So we can take a little bit of this with the tweezers, just on the points, put it on the pads of some components in case we have a lot of troubles to actually solder. This will help a lot in the soldering, but we try to avoid it as the flux is not really good neither for the environment, neither for us, but exists. And this, by defect, is always in the good solder threads. So if we put with the flux on, the solder will flow way easier in general. And you see how it makes liquidy around, because basically it melts and becomes liquidy when you heat it up.
It's like paraffin.
¿Ah?
¿Como parafina?
Bueno, no es exactamente, es bastante tóxica.
Okay.
Those buttons have sides, like positive and negative? Or...
No, buttons have direction. Buttons have direction because they don't connect the same in this direction than in this direction.
So how can we know the direction?
The good point of buttons is they are not exactly square. They are either rectangular. So try to match the footprint. So if you locate the button you will see that these paths are wider than the distance between these two. So try to match it based on the footprint. In that, no, they don't have directionality. Like it's the same in this direction that in this direction. Okay, try to solder a little bit their components. Okay, guys, remotes. Do you have some questions? I can repeat something for you. I don't see you. Wait.
Not at the moment.
Not at the moment. There's Tatiana told us. Yeah.
Ahora revisamos todo al final. ¿Vale? There are some components that are really difficult to solder. For example, microcontrollers or micro USBs or mini USBs, like this one. It's a component that we have like 1, 2, lot of connections here, really close one to each other, and in the other side. So the component actually looks like this. I like to use a technique that is a little bit risky, but in general works well. That is, I first always check that the component matches the location of the legs. Okay, it's perfect. Guys, watch for a second. This one is really important. Components that have the legs really close are really difficult to solder in general. So for example, this micro USB is difficult. So what we will do is first put solder in the big pads. In case we don't have a big pad, we will use one of the small ones. Wait, what is that? Sorry, it's difficult to move the camera. Here, okay. One of the small ones, in case we don't have a big one. Let's locate the component. Sorry, like soldering the camera, looking at the computer is not easy at all.
Eduardo, you are managing well.
Okay, for example, it's not currently located. Let's try to match it better. Okay. So you see the solder is super ugly and the component is not in place. So let's redo it. Let's move the camera. Wow, the thumb is difficult to control. Okay. It's more or less in place, not the ugliest, neither the more beautiful one. You can bend it a little bit, yeah. Let's fix it the other side. I moved the camera, wait. Okay, I just soldered the other side to fix it. Where is the camera? Here. Guys, it's pointing like a 5mm square size. Okay, let's solder the other one. Okay. I will come back to the original one just to hit it better. Okay. I can leave this on solder or solder it, really it doesn't matter. Like the component is really fixed in place. And now, how we proceed with this?
Put it aside and then you put
You run all the solder process. little
Exactly.
ones.
Running each one of them individually is going to be really difficult.
Yeah. So it's like you can put in the side and then
So exactly. So what in general do is I put just in two pads, I put enough and then start running like this. And sometimes I even add more. So the connection seems good, but we have a problem, like everything is shortcutted. So what we can do is a solder sucker or a little bit of soldering bread to clean the connection. And it's almost, you see still a little shortcut. What we can do is now clean really well the point of the soldering iron and start doing a back and forth movement to hit everything properly. Sometimes works, sometimes not. Uh, so a little bit more of soldering bread, solder wick.
it's zero.
It's funny that sometimes happens this. There is almost no solder and the solder wick doesn't take it. It's funny, but the way to fix it is putting a lot of more solder. Why? Because right now we almost have no metal. As we have no metal, it's difficult to heat it. When we have a lot of metal, the heat gets distributed really evenly and really fast. So everything is at the proper temperature. So let's heat it up. Let's put solder wick. You see how it's being absorbed?
Yeah.
Ta-da! Amazing. And we have some clean tips.
So I have a question. The bottom, when you feel it like heating up in your hand before you hold it, like how do you know it's heated properly? Because I always mess up.
Just waiting, like when you see that the solder is getting flow into the copper is the moment that wait 1 2 seconds more and then take it out.
What do you use this for?
Okay, what are these little buttons that we have, like basically it's not for doing PCRs test, is to clean the electronics. So when we touch the PCBs, right now if I hold it like that, I will leave marks of grease on top of my PCB. And that grease will actually make it rust with my fingerprints. So you always, when you finish soldering and you finish also scrapping it, you want to clean your PCB. Recommendation is always to use alcohol and a little piece of cotton to actually clean it well and carefully. Use alcohol or distilled water. I usually prefer to use alcohol. And then when you have it clean, it will not get rusty with the grease of your finger and it will clean and there is no excess of solder, neither flux. When you finish your PCB, what you can do is protect it. I don't recommend to do this step until you are completely sure that your PCB is fully working. So test your PCB, check you don't need to do any resolder anything, and you can do is use nail burnings, to the one that you use for painting your nails, you can use a transparent one to protect it. That will create a protective layer of resin on top of your PCB. What happened? That will avoid that you are able to solder again. So it's a one-way process. If you do it, you cannot fix your PCB again. So be completely sure that the PCB is working. You have commercial products, like for example, Tropicoat, that is the same, but industrial ones. Like you used to, it's like the one that is meant to protect the PCBs, and it's basically UV protecting, and it's acrylic varnish and resists minus 45 to 140 degrees. So it seals your electronics, avoids them to get from getting rusted. So try to practice with a few solder, with a few components.
No, yes, I was asking because I don't know if it's one for you.
Okay, chat. Let's see the chat.
Okay, you have one.
Where is the chat?
This is working. Here.
All are working, yeah.
So, yeah.
Why cannot see the chat? Stop sharing. Ah. Wait, is the chat? Okay. One last tip I want to give you. Where is the camera? Here, here. Cannot start video. Let's wait for it. Start video. Okay. Is these little clamping stations are really good. You have these alligator clips and you have an augmentation lens to fix your electronics. When holding your PCB, these little clamps actually will damage the top of the copper. So my recommendation is always to put a little piece of paper, take a little piece of paper, bend the piece of paper, put it on the PCB in the same location as this, and then grab it with the alligator clip. So like that, the PCB is protected from any scratching from the metal alligator clip, and we will not damage it. You have other types of holders. I like a lot these ones because you can clamp from the sides, and usually they have a little suction cup, so you fix them on the table and they don't move. My personal choice is either to use these ones or going into the minimalistic way and just put the same double-sided tape that you use for cutting the PCB, don't clean it, and just stick it to the table so the PCB is fixed into the table and we can solder easily. Let's. I will check the PCBs that they are soldering. Let's see, guys. Let's see this one. Let's see this one. Ooh, do you think it's good solder? Remote, this is a question for you.
No.
It looks like bubble.
Okay, this one is more or less good. This one needs more heat. Let's see. These ones, they also need more heat. This one is. Let's look. This one is clearly really cold. This one, you are missing a little bit of solder. And this one, let's see. Well, it's not the best, but neither the worst. A little bit of heat will help a little. Just in case, just always heat more. It's weird to damage a component just because of excess of heat. Like, it happens, can happen, and we see it every year. But it's usually the problem is not on overheating, it's usually on underheating.
The soldering has to go in these little, in these ones.
Ujú.
En estos 4.
Sí.
O en 2.
En los 4.
En los 4. Okay.
For example, this is Giuseppe board. He soldered this one. Not bad.
Not bad.
Not
Ahora
bad.
sabes que la primera vez no lo ha acabado, ¿no? Usually, now that you didn't design this, you know, but usually you have the pictures of the components, the file, which is exactly what the components are. Okay. Now you can see.
For example, here we can see that Giuseppe has soldered each line independently. He didn't solder the middle ones because the middle ones are not connected to anything. So in this case, he didn't solder all at once as I did. He soldered each one individually. There are different choices of soldering. Depends on what you're doing and what they are used to solder. Also. Okay, guys, it's time to move to the next station.